Today, I am pleased to welcome back Neil Daswani back to Google. For those who haven't had the pleasure of working with him, he's one of the leading experts in web security. He has strong ties to both academia and industry. He's previously worked here at Google and at places like Docomo and at Stanford. He's written numerous papers, and he's one of the lead authors, or actually the lead author of his book Foundations of Security, which I'm sure many of you have. Recently, Neil co-founded Dasient in order to help address the issues of sites being compromised and hosting malware and potentially being blacklisted. And all of this is the subject of Neil's talk today. So with that, let's welcome Neil.
Thank you, David, for that wonderful introduction. First of all, let me just say that it absolutely warms my heart to be, back here visiting Google and seeing a lot of familiar faces and amazingly talented colleagues. During the time that I spent here at Google, both as an engineer and as a product manager, I was very fortunate and glad to have the experience to work with many of you to help secure various parts of the web. I think that over the years, Google has just done an absolutely amazing job in helping provide online services, providing them in a way that maintains and provides security as well as privacy. And my hope is that together we can continue to keep the internet a very safe place to both work and play online. And so, in my talk today, I will tell you a little bit about some of the things going on in the web-based malware world. One thing that I wanted to get just a quick sense of prior to getting into a more deep discussion is how many of you are from a security or security-related team here at Google? Okay, so about half, and then the other half are not. And I was told that we also have folks attending the talk remotely, as well as I think that this talk may be posted on YouTube as well. So I will be describing some background and introduction. So for those of you that are already familiar with some of the things I'm going to be introducing, please be patient so that we can, make sure that everyone's, together. But with that, let me start by just giving a quick synopsis of what Dacient's about, and a little bit about its history. So I had the pleasure of working at Google for just over 3 years until September 2008. In October 2008, I co-founded Dasient together with 2 additional colleagues, and we, as a company, we're about 9 months old at this time. At the time that I'm giving this particular talk, we raised just over $2 million in seed round funding by December of 2008. We were very lucky to have received investment from some folks that have been very influential, both in the web security world as well as in the web world. So, for instance, Stratton Sklavos, the former CEO of VeriSign, is one of our key investors. In addition, how many of you use Twitter? Yeah, so some of you use Twitter, good. So Mike Maples, who's one of the key investors in Twitter, is also an investor in Dasient. And Eric Benamou, who's the former CEO at 3Com Corporation, is also an investor. So we were very glad to raise, seed round financing in the midst of an economy that was falling apart in many ways. One of the reasons that we were able to do so is because we're focusing on helping various web-based businesses deal with cybercrime and malware attacks. And for those of you that have been tracking the trends, there has just been a lot of pain due to these kinds of things. So we're very glad that we're off the ground, and we're looking forward to continuing to work and collaborate with search engines, with browsers, with browser companies, etc., to keep the internet a secure, safe place. So let me just give a quick outline of some of the things that I'll discuss over the next, I think maybe 40 minutes or so. My hope is that we'll have some time to have some good discussion afterwards. I'll first talk about how there's been a fundamental shift in the way that malwares get been getting distributed on the internet. I'll then talk about a particular kind of malware called web-based malware, and I'll talk about some trends there. I'll talk about how some of these web-based malware issues can be mitigated. As part of that, I'll tell you a little bit about Dascient's web anti-malware platform, and then at the end, my hope is that we can chat a little bit about how we can work together as a community to keep the web a good place to do commerce and collaborate. So to just review what's happened, say, over the past couple decades, there's been some pretty major shifts in how malware or malicious software has gotten distributed, before even the internet was around. So malware initially used to get distributed via floppy disks. But in the late 90s, mid 2000s, most malware and viruses would get distributed via email attachments. So basically, it would spread in kind of a peer-to-peer fashion, where the virus would send an email. It would attach itself to the email. When somebody opened it, it would email itself to everybody in the address book. So that was one class of worms. Another class of worms was of the type where it would work to find some vulnerability in, say, your Windows operating system, and then exploit that vulnerability such that once the vulnerability was exploited and the binary infected one machine, it would then infect other machines on the same local area network. So that was kind of the next phase from the late 90s to mid 2000s, and things like Code Red and NIMDA spread in that kind of fashion. What's been happening since the mid 2000s to present day is that there's been a couple shifts. So one shift is that while in the past most worms and viruses used to get built by people that just wanted to spread it for the sake of it, to build a name for themselves, there's been many more financial motivations to spread this kind of malicious software, and as a result, it's more critical that the bad guys get distribution. So one way that they've been distributing it fairly aggressively is by compromising websites, infecting those websites in such a way so that when users simply visit pages on the website, their computer will automatically get taken by the malware or the virus just by visiting the web page. So this kind of drive-by download activity is pretty unfortunate, but we need to do something about it. And I think that Google was one of the first to take a very aggressive stance to web pages sending drive-by downloads. So Niels Provos and the anti-malware team here at Google have done a great job in flagging search results and flagging websites where they got caught by these issues. So that's a little bit about the evolution of malware. What we've seen in terms of some other statistics from mid-2000 onwards is if we look at the amount of emails that say have infected attachments, one thing we can see from this graph on the left is that there has been a pretty significant decline in viruses and malware spreading that way. So in 2005, approximately just over 2% of emails would be infected with malicious attachments, and that number has come down significantly. On the other hand, the amount of malware and viruses that have spread via malware by infecting web pages has grown quite significantly. So this graph here on the right comes to us with some data from Sophos and Microsoft, and what it illustrates is that back in, say, 2006, there were approximately 5,000 infected pages getting discovered per day, but as of 2008, that number climbed to just about 30,000. So there's been a 600% increase there, and this is just one data set. Given them here at Google, I thought it might be more than worthwhile to cite some of the data that's been aggregated here at Google. So Google maintains a list of flagged sites and list of sites that may be infected with malware. And if you look at the number of entries on that list, that list of entries has grown by over 70% just in the past few months, in the first, say, 6 months of this year. If you go back to, say, October of last year, it's actually been an over 100% increase. And part of the reason that this has been taking place is because the bad guys have just leveraged more and more and more automation. There's also been new types of attacks. So the bad guys, to spread their malware, what they'll very often do is they will query search engines like Google, like Yahoo, like MSN, and they will do searches to find vulnerable software on websites, and they will then launch automated attacks against those vulnerable, say, web applications on those websites. There's other ways that these things have been spreading as well. So I'll talk a little bit about Gumball. I'll talk a little bit about attacks based on FTP credentials. So this activity has been getting bad, and it's been getting worse. And so what does this look like in terms of across the web? So it used to be the case that typically large websites needed to worry about getting attacked, right? So it used to be the case that the bad guys wanted a lot of traffic with each infections that they conducted, and what we've seen, though, is that there's been a significant trend where lots of medium and small size sites are getting attacked as well. So to put this, to make this a little bit more quantitative, how many of you in the audience are familiar with long tail curves? Okay, so a good number of you. So a long tail curve, of course, is a curve in which 90 plus, or a large percentage of the area under the curve comes from the effectively the long tail on the x-axis, right? So it used to be the case that maybe just the largest websites that got the most traffic would get infected, but because the bad guys want a lot of distribution, they're also taking advantage of long tail phenomena. So on the right side, what we see here in this graph is it's a graph of a million websites that are rank ordered from left to right, from most popular to least popular, and the y-axis shows how many of those websites are infected. So there were about a million such websites that went into this particular graph, and they were bucketed in buckets of 10,000 each. And the key thing to notice is that if you look at it, if you look at the top 500,000, you'll notice that there are probably a little bit more infections than, say, in the bottom 500,000. But if you were to draw a line, it would be a little bit slanted. It wouldn't be so far from straight. What that says is that for the sites that were smaller, they are getting attacked almost as frequently, and so that's also indicative of the way that the bad guys are spreading the malware, in the sense that if there's a vulnerable web application, let's say there's a vulnerable blogging package out there, they don't care whether that blogging package is running on a popular or a less popular site. They will go ahead and take advantage of a vulnerability to spread their infection. So that's just a little bit of data about the problem and how bad it is and the breadth. But one question is, well, why is this happening? Why are so many websites getting infected? And one of the other problems here is that there's just so many different attack vectors. So when I was here at Google and was working on the Foundations of Security book and helping various teams at Google secure their web applications, there were a variety of vulnerabilities in web applications, like SQL injections, like cross-site scripting, cross-site request forgery, etc. And those vulnerabilities can be used, they were traditionally used to steal data from websites, or, say, steal a user's cookies. But what the attackers started doing is saying, well, we don't need to steal the data as much. What we'll do is we will take advantage of those vulnerabilities to actually, say, insert data into the database, or inject some code, say, somewhere on the file system of the web server. And once that's done, the code that they inject can be used to initiate, say, drive-by downloads. And I'll give examples of such code. But basically, vulnerable web applications are one attack vector that can be taken advantage of to spread malware. Other classes include user-generated content. So, for instance, if there might be a site where a lot of users are posting comments, if someone, say, even posts the link to something malicious, right, to a malicious executable, you could imagine that if it's socially engineered properly, it might encourage a lot of people to download it. So user-generated content can be one such vector. User-generated content combined with vulnerable web applications can be even more dangerous. So if bad guys can inject script, as what happened with various attacks in the past, like the attack against MySpace back in 2005, then basically in that particular attack, the bad guy was able to set up a profile page that infected other profile pages every time users visited it, and they were able to spread to over 1 million pages within just a few hours. So vulnerable web applications combined with user-generated content can be pretty bad. Now, one might say, well, why don't we just secure our web applications? Why don't we build them securely, or why don't we, correct all the vulnerabilities? And that is definitely a good step. But I think another thing to realize is that the way that a number of infections take place these days is that the bad guys can just, compromise or find the FTP credentials for the website. Once that takes place, then the bad guys can upload anything they want to the website and have total control over it. It doesn't matter that the code was completely secure. The bad guys can still leverage the website. There's also been cases where web servers have vulnerability. IAS servers have vulnerabilities. Apache servers have vulnerabilities. Web administrators very often don't patch their web servers as often as one might like, and so that's another area for attack. And then there's things like network vulnerabilities. You can also have cases where, the website can be completely secure to an extent. You might have an e-commerce site that, say, in addition to generating e-commerce revenue, might have, say, ads on the page. And everything that they're doing on their own might be secure, but if, let's say, a bad guy uploads an ad into the ad network that they're using to populate the ads on their page, right? The bad guy gets a stolen credit card number, uses that to upload an ad, and then those malicious ads that can shown can also be used to initiate drive-by downloads as well as other nefarious types of activities. So here you have a case where a publisher, say a web publisher, is doing everything right, and they maybe even be using a decent ad network, but their site can still get infected, and their site can still infect users. Now, one of the things that I've been amazingly glad to see is that Google has also been taking a very aggressive approach to dealing with malvertising or malicious ads, and has a lot of initiatives to help address that. And I think that the more such defenses are put in place, the better. There's also been cases where websites, especially smaller time websites or even medium-sized websites, where they don't necessarily have the IT structure to build everything themselves, they might use, for instance, a traffic counter to count user hits or whatnot. And the traffic counter that they use on their website can effectively get taken or get infected, and once that happens, then it can infect all the pages on their site that use that traffic counter. So there's just a lot of vectors here. It's in some cases very difficult to prevent attacks, and sometimes you just need to be able to detect and recover from the attacks when they happen. So that's an important theme. I think it's good to do as much prevention as possible, but it's important also to have measures in place that detect and contain attacks. So because of this difficulty to prevent, and because of the fact that the attackers are constantly coming up with new creative ways to cause trouble for the rest of us, I think Niels Provos and Mohib and Panos said it very well in their cybercrime paper that appeared in the ACMQ. They said it is difficult to be completely safe against drive-by downloads, and I think that's true not only of drive-by downloads but other types of web attacks as well. So that's a number of the different ways that websites can get infected. At Dacian, we've been tracking quite a number of these types of web-based infections, and we have been putting together an infection library. And so there's a couple different cases, ways in which bad guys can inject malicious content to a web page. One way to inject it is to inject an iframe. An iframe is an HTML feature that can be used to render invisible frames into a web page, and they have many, many legitimate uses. One of the things that's great about the web is that one web page can bring in content from all kinds of other places. And over the past couple of years, we've seen a lot of mashups and Web 2.0 functionality, which makes a lot of great use of this functionality. Unfortunately, if a bad guy can inject an iframe into a page and get content sourced in from another site, then what that content can do is do things where it can, say, fingerprint what kind of browser the user is using, what kind of operating system are they using, and figure out exactly what exploit to feed that particular user so that they can take their machine just by viewing the page. So iframe injection is one such type of injection. Injections can also take place by inserting unauthorized JavaScript into pages, and the JavaScript can do all kinds of things. In some cases, the JavaScript can render iframes. In other cases, the JavaScript can invoke Flash, or it can use various ActiveX controls or other Microsoft types of features. Not to say that anything is wrong with Microsoft in particular. It's just that there's a lot of software that's on computers. So the JavaScript could also take advantage of, say, Adobe PDF vulnerabilities or whatnot. So JavaScript injection is a second type of injection. A third type of injection is an injection where the bad guy takes advantage of a functionality of a web server and injects some code, which I'll show an example of in the next slide, where what they could do for the web server is make sure to direct users that access that web server to another web server of the attacker's choice for either any request that comes to that web server or even just, say, some requests. So this graph here shows some data from Dacient's infection library, where we looked at a whole bunch of infected web pages and websites and just cataloged how many distinct types of iframes, JavaScript, and or redirect attacks were taking place on that set of websites. And what we found is that we've cataloged over 10 to 11,000 unique types of infections. What we see is that it's about equal between the iframes and the JavaScript, and there's very few such distinct redirect attacks. So to provide more technical explanation of, or to provide some technical examples, right? I just on this slide put a couple examples. One where an iframe is injected into a website. This particular iframe sources in some content from a server in China called Beach House Name, probably not a legitimate server. And what you might ask, well, if there's stuff getting rendered, stuff getting injected into web pages, how come users don't see it? Well, what the bad guys do is that in some cases they'll set the width and or the height of the iframe to, say, 0. In other cases, as exists with this particular piece of code, it says that the style that the iframe should be rendered in should be hidden, so that users don't see it. And sometimes even when the webmaster looks at the page, unless they look at the code and go through every line of it, it's hard to see it. There's also examples of these types of things in the Ghost in the Browser paper that Niels Provost and company put out. But these are just some more examples. So to give an example of a JavaScript injection, the second bullet here shows some JavaScript code which is obfuscated, and when this code runs, it will basically produce additional JavaScript which sources in some content from these IP addresses. So a couple points about this kind of infection. So firstly, one might ask, well, why would anybody, any webmaster that sees this kind of code on their page think it's legitimate? Well, if you look at various types of web widgets and you just look what's going on the web, there's more and more JavaScript that's getting used on the web. And so if you look at things like a PayPal buy button or whatnot, there's just tons of hex encoded stuff, and so a webmaster may very easily get confused and think this is legitimate. Another phenomenon that you see is that very often the person that builds the website is also not the person that's responsible for maintaining it. So when the bad guys do some of their injections, in some cases, what they'll do is they'll insert additional JavaScript comments saying, oh, the Yahoo counter starts here, or whatnot. Well, of course, there may even be no such thing as a Yahoo counter, but the person that's maintaining the web page may or may not know that and may hesitate to take that code off right away, which basically gives the attacker time to have his code on there longer while more and more users download it. So that's one point about these JavaScript injections. Another point is that if you look at the script that gets rendered by evaluating this JavaScript, you'll notice that, for instance, it has some IP addresses in it. In general, having direct references to IP addresses probably is not a good thing. In this particular case, it could very well be machines that the attacker has compromised on a botnet. And where what they do is they'll run a web server on that machine, so that compromised machine can serve malware drive-by downloads and or other bad stuff from these particular IP addresses. So that's an example of injected JavaScript code. A third example is a type of injection which is a little bit different, where what the bad guys will do is they'll take advantage of an Apache module called mod rewrite, which is installed on many Apache web servers to basically allow the webmaster to rewrite URLs to either make them easier to index by a search engine or for just various other purposes. In this particular case, once this code gets injected into a file called htaccess on the web server, what it will do is when users visit the website, if their browser came to the website with a referrer from Google or AOL or MSN, basically if the user was, say, only searching on Google, AOL, or MSN and gets redirected to this site, will it say, okay, well, instead of serving the user the actual content, employ this rewrite rule so that it doesn't matter, whatever you were supposed to serve them before, you will instead serve them this URL, http 89.28.13.204, whatnot, and that URL is basically hosting some malicious code. So that's an example of a web-based malware infection. These kinds of web-based malware infections have been getting pretty significant. Just earlier this year, there was a significant infection called Gumball that started to take shape in late April 2000 of this year, 2009. And the way it worked was interesting. It was basically a combination of a number of different types of malware. One type of malware would, when it's on the user's PC, it would log all the user's keystrokes. And if that user, say, logged into a website via FTP or whatnot, it would log all of the passwords that were used to access the website. It would send all of those passwords to the bot master. The bot master machines would then automatically conduct attacks against that site whose credentials were just stolen and auto-inject more drive-by download code into those web pages. What would happen at that point is because the malware code was now on more web pages, more people would end up having the drive-bys happen to their machines, and it basically created a positive feedback loop where the attacker just had this botnet and set of infected pages grow and grow and grow and grow. It basically took over 80,000 sites in a very short time period. So basically the bad guys are using automatic scaling of attacks. The code on this page is actually some of the Gumball code. Some of the things to note about this code and note about Gumball is one of the things that Gumball was doing is it was infecting each different website with completely different code, kind of polymorphic code. So one could say, well, this should be easy. I should just look on my web pages and I should look for, certain types of code. And even if the code looks like this, maybe I can write a regular expression that can capture what it looks like. But the problem is, of course, such an approach could just be extremely, extremely fragile. So that's not going to work. Looking for signatures is also not going to work because the attacker can just change things way too easily. It's very important when looking at such infected pages to look at the behavior of the page. What is the thing actually doing? What code actually gets executed? Question? So the question, could this attack be for static HTML or dynamic HTML as well? And it could be both. It could be either, right? So for instance, one could inject this kind of code into a database that is used to, say, drive e-commerce on a site or drive a blogging package on a site, and so the pages can be completely dynamically generated. In fact, one trend is if the attacker can inject such code and say to the header or the footer of the page, they'll basically take every page on the site. So that's a bit about Gumball. So because of this, it's I think imperative that we work together as a community to make sure that the web stays a safe place to do business in. And so as a result, there's been a lot of great initiatives here at Google. The anti-malware team has done a wonderful job of protecting users against these kind of threats, not only in Google search results, but also in in just regular browsing activity. So, I had mentioned the Ghost in the Browser paper, and that's a great paper to read if you want to learn more about what Google's doing. But basically, and certainly we have the experts in the audience here. One thing to note about what's going on here is that Google is, after it crawls web pages and indexes them, they are scanning such pages for infections, and there's an awesome system that's in place to do that. And when it finds something, what it does is it will, when it shows search results, it will mark those search results. It'll flag them by saying this site may harm your computer. So that is one initiative that's taking place to protect users, and it's I think Google pretty much led the charge here in many ways. So there's also been a number of other quote-unquote blacklists or flag lists that mark pages and warn users away from scary web pages in other ways. So for instance, there's an effort called Norton Safe Web, and it also looks for drive-by downloads and phishings. But actually, before I get into too much detail, let me first just mention some of the advantages about the way Google is doing things. When Google flags drive-by downloads on pages, it's a binary, this page is infected or it is not. And they do it in a very pure, truthful way, meaning if a web page is visited and a malicious binary comes down, there are no if, ands, or buts question about whether or not this page is malicious. They're also very careful about how they go about marking web pages as infected. So that said, there's a number of other initiatives here which not only which seek to not only kind of flag that type of behavior, but flag other behavior that's kind of a bit more in the gray area. And there's various trade-offs, pros and cons of doing that. So let me chat a little bit about that. So Norton Safe Web is one such website. So users can go to Norton Safe Web and type in a domain and see if that web page might harm their computer. There's also a toolbar that they can download that will warn them of such things in their regular browsing activity. So they also look for other things like spyware, viruses, worms, dialers, browser changes, and even just software that's hard to uninstall. And so because of the fact that they're looking for much more thing, and there's much more gray about what's going on, they not only mark some sites as red, warning, this is scary. They mark some sites as yellow, caution, basically signifying to users that this may be in the gray area. They mark some sites as safe. They mark some sites as untested. McAfee Site Advisor, similar thing at work, where they are checking for a variety of other things. Notice that what everyone's checking for is just a little bit different, and I'll give some stats on how that practically plays out. So with McAfee Site Advisor, they also have such labels. How does this manifest itself in terms of user experience? So when a user, visits Google, if they do a search and they find that there's a infected web page in the result, then Google will tell them this site may harm your computer. My guess is you guys all know this. Google, of course, all also shares that list of infected websites with popular browsers like Firefox and Chrome. And if one was to arrive at such a site, not just when they're searching, but just through regular browsing, they will see, this red screen of death saying that this is a reported attack site. Internet Explorer and Norton also have been doing such things. So Microsoft, in the most recent release of Internet Explorer 8, basically also included anti-malware protections, and if one ends up at a infected web page in Internet Explorer, they see a screen like the one here on the bottom left. And Norton has a number of things as well that show this in a user interface. You can imagine that if you end up at a infected website and you're running an antivirus product, you will see some kind of warning come up. So that's what's happening. I chatted a little bit about the fact that these lists are all looking for slightly different things. And so on this slide, I have a couple different graphs. So we ran an experiment at Dascient where we took a bunch of domains, and we looked them up on various such lists, and we looked at, well, how many were flagged by Google, how many were flagged by Norton, how many were flagged by McAfee. And what we can see is that different numbers of things were flagged. Google flagged the smallest number of things, but keep in mind that Google is very conservative comparatively with regards to what they mark bad. Norton and McAfee, will flag things that are kind of also in the more in the gray area, and things that are, say, not just drive-by downloads. To provide some more stats, across the set of sites that were listed on one or more of these lists, overall, 57% of those had a red label, a warning label, and associated with them, and 43% of them had a caution label associated with them. And then the numbers came out for Google, Norton, McAfee, and so it's also interesting to compute an intersection amongst these lists. And one of the key things to note from this Venn diagram, it's not exactly to scale, but it's about right. One thing to notice from this diagram is that there was a very, very small overlap actually between all three lists. Under 1% of the domains were in common in between all of these three lists. So this basically has a couple implications. One implication is that question? We got the list of domains from Alexa, actually. It was basically a list of popular domains on the internet, and we sampled 10,000 of them. I'm sorry, what was that? I'm sorry. Ground truth. So the question is, how did we establish any ground truth? Actually, we didn't attempt to come to any ground truth. We just looked at intersection between the lists. That's all that we did.
So the list you got appears to have 100% either warning or caution.
Right. So this is just the list of sites that are blacklisted. Yeah. Okay. So anyhow, it tells us a couple of things. It tells us that users, like for a webmaster to keep up with all of these different lists can be challenging, and so that's why Dascient, one of the first things that we made available in terms of services on our website is a service which will check sites against all of these lists, for free, and just email them, if they ever appear on any of the lists. So that's one thing. The other thing is that there's various definitions of what's bad, right? And everyone has a different definition of what's bad right now. And as an industry, it would be great to come to some convergence on what's bad. So in any case, that's some data. We actually just issued a blog post about this particular item, this particular experiment this morning on Dascient's blog. So feel free to check it out. So because there's been a number of because when a webmaster has something bad happen to their site, it's important for them to be tools. And Google also took the charge here and was the first to, in their webmaster tools, when people have problems with their sites, they can go to Google's webmaster tools, and if their site, say, is infected with malware, the first thing that they're told on the webmaster tools dashboard is that the site may be distributing malware, and gives them sample URLs, and it's absolutely very useful for site owners. At Dascient, we've been developing a set of technology and a set of initial products to also help webmasters and help web hosting providers deal with these problems at scale. So I think what I'll do is I'll tell you a little bit about what Dascient is doing in this space. So our company just came out of stealth mode about a month and a half ago, and the initial set of products that we offer are shown here. We offer to help both webmasters and web hosting providers. We offer them diagnostic and monitoring services where let's say that a site wants to check whether or not they're flagged on any of these lists. They can do that. Or if they happen to be infected, we can give them diagnostic information about what's taking place. We provide monitoring and alerting services so that they can get scanned on a regular basis. So that's a little bit about what's available on the diagnostic and monitoring front. And I'll show you demos of these things. Another thing that we made available is that we've been in discussions with lots of customers and listening to their pain points, and also thinking about it from an engineering standpoint about what can we do to help them. So a lot of the cleanup activity that's been taking place thus far has often been very manual, right? Whether they're, regardless of what tools that the webmaster or the web hosting providers are using. And so we felt it would be important to also make available remediation tools such that if and when a site gets infected, there can be an automated response. So if you think about what happens with the desktop antivirus, what happens with desktop antivirus is that if your machine, say, gets infected, then there is antivirus software in place which will not only identify the infection but will attempt to quarantine the malicious file so that you can effectively continue your work. And we would like to bring the same model, and I think it's important to bring a similar model to the world of the web and to websites. So instead of when a website gets infected, just telling them about the infection and then giving them some information so they can manually resolve it, it might be really good to have a system in place so that the infection gets automatically quarantined and the web server doesn't serve any malicious code. And I'll show you an example of how that works, and then perhaps we could chat about some ways that we could potentially work together. So to just give you now that I've told you a little bit about what some of the initial products we've brought to market, and after our initial press launch, we were just very glad that the products were very well received. We got a lot of attention in the media, which is great. And we basically are excited about developing more and more to help the community. So I've told you a little bit about what's been done thus far. Let me tell you a little bit about how Dascient's system works. The goal here is to bring kind of the life cycle of malware protection to most websites. So by life cycle, I mean that we need to not only, say, monitor a customer's web server, but we also need to quarantine the malicious code on that web server. So basically, the way our system works is we have a crawler that will take the first step and discover all the resources and URLs on the system. That information, that set of URLs, is fed to a set of content analyzers. The content analyzers, as you guys are all familiar with, web pages are just becoming more and more complicated. And so, if web pages were just HTML, that would be one thing. But if there's all kinds of things on web pages that can execute and run and need to be clicked on and such things, then it's important to make sure that one can dynamically, behaviorally look at what's going on there. So basically, that's what the content analyzers do. That information is fed off to a set of malware analyzers that will look at a whole bunch of features of the web page and what's going on, and figure out is there something bad going on here? Has the page been infected? That information is shown to, say, webmasters through a user interface, but that information also gets sent to a web server module that we install either on the customer's web server directly or on the web hosting provider's platform, such that if and when an infection happens, these quarantining instructions sent to the web server tell the web server how to not only identify but eliminate the malicious code on the website. So given that overall architecture, let me show you how it works. So, and instead of showing you screenshots, if the demo gods are with us and if the internet connectivity works, let me just show you how it works in real life. So if you come to Dacient's website, one thing you can see is that we provide some diagnostic tools, right? So I'll enter a site called, say, thejumpeat.com and hit diagnose, and what it'll do is it will, looks like our internet connectivity went away. Let's see if we can get it back. Okay, good. So once we enter the domain, our service starts doing a quick scan of the website. It's determined that the website is blacklisted and infected, and it's now scanning the website to find the malicious code. And it says that it's found the malicious code. It's found it on this particular URL on the home page, and once it gives the report, we can click it, and it will show the exact code snippet from the site that's infected. The other thing to keep in mind is that this is the diagnostic service. We also have various monitoring services, such that if and when a website gets infected, folks can sign up for the monitoring service, and we'll do a daily or more frequent scan of their site. And if and when the site gets infected, then basically we'll send them an email saying that in this particular case, a site called gnupods.com may be infected. It's not blacklisted yet on Google, on Firefox, on SafeWeb, on SiteAdvisor, but if the infection's around long enough, it wouldn't be surprising if that indeed does happen. So one can click here for a report, and I'll just go ahead, go to the report. The report is over here. So gnupods.com is infected. It's at a risk of getting blacklisted. The reason it's at a risk of getting blacklisted is because there are 2 infected pages that have been found on the site. There's 7 pages that were scanned. There were 2 infected pages. If we would like, we could see a little bit more detail about the infection. So it tells us that the infection that's found is an iframe to baddomain.com. If we click on that, it will take you off to Dacient's infection library, where it gives you just a little bit more information. It says, this is a malicious iframe. The code length is 37 bytes. Of course, this is a very, very simple example that I'm using just for the purpose of this demo. 99.9% of the code that we find is much more complicated than this. And over time, we're going to be adding more and more to that infection library. But in any case, once the site owner receives the report saying that the site is infected, we now want to resolve it, and we want to resolve it in as automated of a fashion as possible. So what exists in the lower part of the report is, as before, the URLs that are infected and the pieces of malicious code, but there's also this box that says protect my users from these infected web pages. And if the webmaster clicks this box and clicks update, then what our backend servers do is they will establish an SSL connection with the customer's web server, connect to the web server module that we provided them with, send over quarantining instructions to that web server, propagate those quarantining instructions across all the web server processes and the web servers running on that site, and eliminate the infection. So let me just step back for a second and shut off the protections. So let's say that the site in question here is this gnupods.com site. It is a blog. The blog owner may have some articles that they post. People can post comments, etc. They may put ads on the site and earn their revenue from it. But basically, this blog is infected. So On this page is an iframe that was injected into the site through a user comment. And one of the things to notice is that, well, we actually see the iframe. Of course, if this was a real attack, we wouldn't see the iframe. It would be invisible. But the second thing is that, well, in this case, the actual drive-by download is also not coming to my machine because I didn't want to infect my machine. But the idea is that, this page is infected. If, say, Google's crawler were to come along, or Norton SafeWeb were to discover the site, or McAfee Site Advisor were to discover the site, then this page could get blacklisted and would become inaccessible to users. To prevent that from happening, when the site does get infected, we send the user this report, and if they click this protect my users from these infected web pages box and click update, and the SSL connection happens, the quarantining instructions get sent over, etc. If we simulate, say, being another user coming to the blog by hitting reload, then once the quarantining instructions have been propagated, let's see if they've been propagated. Yes, they have. So the page gets served exactly as is, except the malicious code has been stripped out of the page so that the website can continue operating as such, without being impacted by the infection. And so that's one of the technologies that Daswani has built and is working with a number of web hosting providers and deploying on their platform so that we can bring end-to-end web anti-malware protections to websites. So that's the demo. Let me switch back. Let's see here. Okay, so you guys got to saw the real thing. So what's some of the work that we've done to date? A question?
So, if you're able to identify the snippet accurately and you have access to the web server, why not just remove the snippet instead of disabling the whole content?
I'm sorry, so the question is, if we were able to identify the snippet, why not just take out the snippet? Right? That's exactly what we did in the previous example, right? No, we did not disable the access to that particular web page. That web page got served. It just got served without the malicious code on it. Exactly. Now that said, we also have the technical ability to say just block the page, right, so that the malware wouldn't get served. That's doable as well. And so we've had various requests from customers. We've had different customers request different things, blocking versus quarantining. But the key point is we can do the quarantining, which is the more complicated thing to do technically, and we're glad that we're able to make that technology available. The other thing is that in the example that I showed you, the Webmaster received a report and had to click a checkbox. Some customers have basically asked us, hey, we'd like you to just automatically quarantine the infection, right? And then maybe just let me know you did that afterwards, and we're happy to do that too. And it really depends upon what kind of company it is and their web servers and what processes they have in place on the business side. So to date, we've been glad that we've been able to help thousands of websites. We've been doing so through a variety of ways. We, Google helped create this organization called StopBadware.org and provides them with a lot of data. And StopBadware.org created a community called BadwareBusters.org. We've been interacting with sites that have been infected through BadwareBusters.org, sending them free reports, helping them with their malware problems. We've also notice that some of the moderators of these communities have also been using our tools from time to time to help not only on the badwarebusters.org forum but also on the Google Webmaster forums. So we're very happy to have made these things available. In addition, we've been working with a number of web hosting providers. So for instance, a web hosting provider, they don't want infected domains on their platform, and so in the work that we've been doing with web hosting providers, we can do things like scan all their domains. We, in many cases, work with them to deploy our quarantining technology on the web server, which is available both for Apache and IIS, by the way. We also and I think there's been some good interactions to date. So there's been cases from time to time where one has worked together with other folks in the community to say get lists of infected sites and help out the web hosting provider. And we'd like to do this at scale because we want to protect large portions of the internet in one shot. We've also been doing this through a whole bunch of third-party affiliates. So there's various, web design companies that that build websites for a living. And we are excited about working with those types of folks so that they can just bring our malware monitoring services to their customers. And certainly for both of these sets of folks, web hosting providers as well as third-party affiliates, we're also happy to provide them with free blacklist monitoring across not only the Google blacklists but the the McAfee Site Advisor and the Norton Safe Webs, etc. So we've been offering a set of things to the community: quick scans, blacklist monitoring, informational resources. The folks that we've worked with have had very good things to say about us thus far, and we're just very excited about continuing to please them and help them with their malware problems. That said, I think that there's a number of collaboration opportunities in front of us. So my hope is that this talk is the start of a dialogue and the start of a discussion where we can figure out how we can work together as a community. So, for instance, one of the reasons that the bad guys often get ahead is because they happily share attack techniques and data all the time, right? In some cases, they buy and sell it from each other. In other cases, they actually just exchange the information. And I think that on the good guy side, we should also do more and more data sharing. If it makes sense to say create a close-knit, trusted consortium of sites or companies to do this, that might be good. But for instance, if I look at what are the sets of things that say Google detects versus what's the set of things that Dasient detects and what's the set of things that Norton and McAfee detect, these are all overlapping Venn diagrams. I don't ever expect that they'll be and in some cases they're non-overlapping, right? And different percentages are non-overlapping. I don't expect that there will ever be one completely overlapping circle for everybody. But I think it might make sense to make sure that just given the data that we saw before, where it looks like there's a lot of differences between what people are looking for, coming closer together on that. So my hope is that there might be some way to share information, say about gray area attacks, new attack classes, attack types, sites that may be infected but not malicious. We're not quite sure if the code is actually bad. That's one area of opportunity for collaboration. Other areas of opportunity are we've created this quarantining technology for web servers, and we've also created a number of other tools. And one question in my mind is, would there be a way to make some of these things available via open source communities? So for instance, if some of you were interested in working on open source projects on the side, please come to me afterwards and or send me an email. My contact information is here, and let's figure out how we can make some of these tools available open source. Finally, we have connections to Stanford. Dan Bonnet at Stanford, Professor Dan Bonnet there is an advisor to our company, and so we have a connection with Stanford. We have some affiliations with some other universities. I know Google also has connections with a lot of universities, and I think that academia has a lot to bring to the table with regards to not only data sharing but also analysis and whatnot. So I guess with that, I wanted to just leave it open for discussion for ways to collaborate. I look forward to working together, with Google, with other search engines, with browser companies, with various folks as a community, so that we can make sure that the internet stays a great place to communicate, collaborate, conduct commerce over on, and keep the web malware free. With that, thank you for your time. And I'm happy to take maybe one or two questions. And for folks that would be interested in discussing more, you can also come up afterwards. Okay, I think what we'll do is maybe let's just go directly offline, since we might be a little bit over on time. Oh, actually, one question. Yes, go ahead. One question.
When you sanitize those snippets, is that always so easy? Are they always so isolated from the rest of the web page? I can imagine cases where an attacker would want to make the snippet very integral to the functioning of the web page, so that you would DOS the web page to pick it up.
So the question is, is that snippet always so well contained that you can just take it out of the web page and make everything work? And certainly we expect that over time the attacks will become more and more complicated. But even then, there's a lot of ways that infections happen. And in most of the cases we're able to quarantine the code. The bad guys will get more and more sophisticated. It's an arms race, so we'll have to become more sophisticated too. There's, by the way, other types of attacks where the bad guy says, well, the heck with infecting any of the web pages. I'm just going to take control over the domain name, right? And so basically, whenever we possibly can, we will quarantine. If we can't quarantine, we will at least block the infected web page from going out. Basically, the more techniques that we have at our disposal, the better that we can do as the attackers also continue to escalate. One more question, and I think we'll break.
How easy to scan a web page? Would it make sense to make the scanning more to the web browser that runs constantly?
Okay. So the question is, how complicated is it to scan a web page, and should we just make it part of the browser? Or a part of Apache. Okay. So scanning web pages for malware is very hard. There's a lot of different things that can go wrong, and I think that building as many browser-side defenses as we can would be a good idea. And to an extent, with Google providing, say, that information to Firefox and Chrome, that's a great step in that direction. It's a very quick check that a browser can do. But I think we need to keep those checks quick because browsers already have so much stuff that they already need to do. With regards to what kinds of protections that can be put into a server, my guess is that over time more and more protections can be put into servers, and that's a good area to go down. But basically, the scanning itself, is very complicated, and it can sometimes involve, multi-level, interpreting content, multi-level, looking at plugins, looking at also just things that could go wrong in the OS around the browser. So it's just probably too much to do in the browser. So in any case, I think with that we'll leave. I'll be happy to take questions offline, but I hope everyone came in and learned at least one thing they didn't know before. Thanks once again for your time.